Hello everyone, welcome to my this video lecture on Hanning window. Myself Sirisha, today I am going to teach you about the Hanning window techniques. As we all know that we are going to have the FIR filters techniques. We are in the topic of FIR filter designing methods. We have completed the Fourier series method, and as well as now we are entering into the window techniques. Window techniques, we have different types of window techniques are there. One is rectangular window, Hamming window, Hanning window, Kaiser window, Blackman window, etc. But for the examination purpose, the Hamming window, Hanning window are very important. So on the basis of the request from the students, today in this video lecture, I am going to teach you the Hanning window. Now without any delay, let's get into the problem. Now let us say do the problem based upon the Hanning window. So whenever you are solving the Hanning window problem, first of all you have to remember the Hanning window function. So I have given you the Hanning window function WH of n equal to 0.5 plus 0.5 into cos 2 pi n by n minus 1 for minus of n minus 1 by 2 less than or equal to n less than or equal to n minus 1 by 2 by 2. See, and it is equal to 0 otherwise. See, whenever you are going to solve the problem based upon the Hanning window, it is most important to remember this formula. Without this formula, you can't do anything. Okay, so you have to remember this formula. So 0.5 plus 0.5 into cos 2 pi n by n minus 1 for minus of n minus 1 by 2 less than or equal to n less than or equal to n minus 1 by 2. Now let us solve a problem based upon the design of high pass filter with the frequency response HD of e power j omega is equal to 1 for pi by 4 less than or equal to modulus of omega less than or equal to pi, and it is equal to 0 for modulus of omega less than or equal to pi by 4. So this is the high pass filter frequency response, and he is asking us to, using the Hanning window, find the h of n value for n is equal to 1, find the h of z and plot the magnitude response also. Okay, now you have, while solving this problem, you have to understand the this frequency response. You have to plot the given function in the plotting form. See here. Now step 1 is find out the desired frequency response. Okay, so the desired frequency response is shown in below. He has given HD of e power j omega. Now see here, this is the HD of e power j omega. On x-axis, on y-axis I am taking the HD of e power j omega, and on x-axis we are taking the w. Okay, now so he has given from the omega has given modulus of omega minus pi to pi minus pi by 4. Its value is equal to 1, and from pi by 4 to pi also its value is equal to 1. So this is the pictorial representation. This is the pictorial representation. This is the pictorial representation of HD of e power j omega, which has given in the problem. Okay, now from this we have to find out the h of n, default h of n. So HD of e power j omega has been given. It is the frequency response. It is in the Fourier transform method. No, you have to you have to convert that into the h of n. By what? By applying the inverse Fourier transform. You know the inverse Fourier transform formula. The inverse Fourier transform formula is HD of n is equal to 1 by 2 pi of minus pi to pi HD of e power j omega into e power j omega n into d omega. So this is the formula. Okay, now we are applying that formula. See here, after applying the formula, according to that, HD of e power j omega is equal to 1. This function is existing between minus pi to minus pi by 4 and plus pi by 4 to pi. So that's why in these two only HD of e power j omega value is equal to 1. So 1 into, so now this equation has been converted into 1 by 2 pi of minus pi to minus pi by 4 HD of e power j omega value is equal to 1 into e power j omega n plus pi by 4 to pi. Again HD of e power j omega value is equal to 1 and e power so 1 into e power j omega n into d omega. So it has been converted into like this, because in these two regions only HD of e power j omega value is equal to 1. In the rest of the regions HD of e power j omega value is equal to 0. 0 into something is equal to 0. That's why we didn't mention that. So we have to split the integration into these two parts. Okay, after applying the integration, e power j omega, the integration of e power j omega n is equal to 1 by jn into e power j omega. So 1 by jn is we have taken into common. So here also we will get in the first function also, in this function also you will get the j omega n, and in this function also you will get the 1 by jn. So you have to take common as 1 by jn. Already in the common we have 2 pi, so 1 by 2 pi into nj as common I have taken. So here after applying the upper limit minus lower limit also, we got this equation. After getting this equation, I am converting this into e power e power j theta, e power minus j theta by 2j is equal to sin theta, right? In place of j theta we have a jn. So you have to convert this into e power minus j pi n by 4 minus e power minus j pi n by 4 as sin pi by 4 n, and e power j pi n plus minus e power minus j pi n by 2j is equal to sin pi n. So the total this function has been converted into this 1 by pi n into sin pi n minus sin pi by 4 of n. So but these limits are from minus infinite to plus infinite. Okay, now but here the n value is minus infinite to plus infinite, right? But we have to truncate this value to the 11 samples only. So we are this is the causal function and the even function. That's why the causal function means you have to truncate this value 11 samples, means total minus of n minus 1 by 2, right? So n value is equal to 11 minus 1 by 2 means 10 by 2 means 5. So total modulus of n is less than or equal to 5. So here you got, see in the given problem they have n is equal to 11, right? N is equal to 11 they have given. So the limit values are minus of n minus 1 by 2 plus n minus 1 by 2, right? So n value 11 minus 1 by 2, so minus 5 to plus 5, total minus 5 to plus 5 you can take, right? That's why if you take as it is a causal function, you can take the modulus of n less than or equal to 5. So total 11 samples truncating means you got the h of n is limited to 5 only. Okay, this is the function. Now you keep it here. This is the first step. Now come to the Hanning window. So this is the formula of the Hanning window. This is the formula of the Hanning window. So WH of n is equal to 0.5 plus 0.5 into cos 2 pi n by n minus 1 for minus of n minus 1 by 2 is less than or equal to n less than or equal to n minus 1 by 2. This is equal to 0 otherwise. Now this is the Hanning window. We have to find the window coefficients, right? So window coefficients means 0.5. How will you get the window coefficients? You have to get the window coefficients by substituting the appropriate values of n in the given equation, in the given window equation, right? So n value here we know that the n value is less than or equal to 5. So you have to substitute n is equal to 0 in place of small n. If you substitute in n is equal to 0, you will get 0.5 plus 0.5 into cos 2 pi into n value is 0, capital N value is 11 minus 1, right? So you will get 0.5 plus 0.5 is equal to 1. So this is the well, in the same way, you have to find out WH of n value for n is equal to 1. And as it is the causal function, you WH of 1 is equal to WH of minus 1. You don't need to calculate the WH of 1 time, WH of minus 1 time, right? So WH of minus 1 is equal to WH of 1. So is equal to 0.5 plus cos 2 pi into n value 1 minus 11 minus 1. So if you do the calculation, you will get the value 0.904. So like that you have to calculate WH filter window coefficients for n value from 0 to 5. So n value 0, 1, 2, 3, 4, 5. I have calculated this. See guys, without a calculator you can't do this problem. Okay, one thing is you have to identify the filter coefficients. So for finding the filter coefficients you need to have this formula, but the n value we have truncated to 11 samples. So capital N value is 11 samples. So capital N value, if you get minus of n minus 1 by 2 to plus n minus 1 by 2. So if you substitute, the n value is lying between minus 5 to plus 5, as it is a causal function. So minus of n value is equal to plus n value. So that's why instead of calculating minus 1, minus 2, minus 3 values, simply I have started from 0 to 5. Okay, 0 will be the middle one. Next, after finding the window of coefficients, now it is time to calculate the filter coefficients. Already we have find out the filter values, right? So this is the final value we got. Right? Okay, now for in this also you have to substitute the different values of n and you have to find out the filter coefficients. After finding the filter coefficients, after finding the window coefficients, we have to multiply these filter coefficients and the window coefficients together, then we will get the coefficients for our problem, right? So this is the formula for n values from minus infinite to plus infinite, right? So now I am taking that formula. So the see here, from the filter coefficients can be obtained from hd of n is equal to sine pi n minus sine pi by 4 into n by pi n. So here you have to substitute the n value 0, 1, 2, 3, 4, 5. Okay, but for the initial value I am not substituting the n value directly, because if you substitute the n value directly, so pi into n value means pi into 0. So pi into 0 means this total function will becoming the indeterminate value, right? So this value, see here, if you substitute n value is equal to 0 here in the denominator, if you substitute n value 0, this total become the indeterminate value. That's why we will not apply n is equal to 0 for this one in this case directly. So for that we are applying the L'Hospital rule. So L'Hospital rule is applied for the such functions where the function is indeterminate or not existing one. So instead of applying the direct n value, we are applying the limit values for the n is equal to 0. Right, so hd of 0, if you substitute n is equal to 0 here, hd of 0 will become hd of 0 is equal to limit n tends to 0 sin pi n minus sin pi by 4n into pi n. So this value is equal to 1 minus 1 by 4. This value is equal to 0.75. You apply the limit values. Now only for this value. Now rest of the things you substitute. You substitute hd of 1. hd of 1 is equal to hd of minus 1 is equal to, in this you substitute sin pi into n value 1 minus sin pi by 4 into n value 1 is equal to pi into 1 value. Okay, so you will get this value. So like this you substitute hd of 1, hd of 2, hd of 3, hd of 4 and hd of 5. So these are the values we got. So 0.75 minus 0.225 minus 0.159 minus 0.075 and 0. So these are the values we got. After getting the filter coefficients, after getting the window coefficients, you have to multiply these two together for the filter coefficients of our problem. So therefore h of n is equal to hd of n into whn of n. So I am multiplying this value 0.75 into 1. So this is the value we got, 0.75 for this, and WH value is equal to 1. Here, see here, this is the WH value, this, and the HD of 0 value is 0.75. So I am multiplying these to 0.75. Similarly, you are going to find out the H of 1 value by substituting HD of 1 and WH of 1. H of 2 is equal to HD of 2 and WH of 2. You are multiplying those two values, you will get the filter coefficients of our problem. After getting the filter coefficient values, then next step is finding the transfer function of the filter. Transfer function of the filter, this is the formula for calculating the transfer function of the filter. H of z is equal to h of 0 plus sigma n is equal to 1 to 5 h of n into z power minus n into z power n. So here h of 0 you got, already we got h of 0 here, 0.75 is the h of 0. So substitute that 0.75 minus plus n value should roll from 1 to 5. N value, you roll the n value from 1 to 5. For example, n is equal to 1, h of 1 into z power minus 1 into z power n. So h of 1 is equal to minus 0.204. So minus 0.204 into z power minus 1 plus z power 1 minus n is equal to 2. N is equal to 2 means, see here, n is equal to 2 means h of 2. h of 2 is equal to minus 0.104. Minus 0.104 into z power 2 into z power minus 2. In the similar way, you have to substitute the n value from 1 to 5 and finding this equation. Okay. Next is, see, h of 4 and h of 5 we didn't substitute because h of 4 value is equal to 0, h of 5 value is equal to 0. So 0 into something is equal to 0. That's why our filter h of z is limiting to z power 3 and z power minus 3. So this is the h of z. But this is not the transfer function of the final filter. The transfer function of the realizable filter is equal to h bar of z is equal to z power minus of n minus 1 by 2 into h of z. So z power minus 1 by 2 and z power minus n value is 11. 11 minus 1 by 2 means minus 5. So z power minus 5 into h of z. So z power minus 5 into this is the h of z, right? So this entire equation I am substituting in this form. So z power 1. So now multiply this 0.25. 0.75 into z power minus 5 minus 0.204 into z power z into z power minus 5 is equal to z power minus 4. Like that I am substituting the entire thing. So z power minus 1, z power minus 1 5 is equal to z power minus 6. So like that you substitute the you multiply z power minus 5 value to this entire equation. So this is the equation you are going to get it. Okay, so h bar of z is equal to, now just I'm rearranging this equation according to the weights. So first z power minus 2, next z power minus 3, next z power minus 4, minus 5, minus 6, minus 7 and minus 8. So I'm just rearranging this equation. So now this is the causal filter coefficients are h of 1 is equal to, so see here, h of 1 is nothing but h of 0 we don't have, and h of 1 is also we don't have. H of 2 you may have because z power minus 2 we have, z power minus 3 is also we have, z power minus 4 is also have, z power minus 5 is also we have. H of 9 and h of 10 we don't have because z power minus 9, z power minus 10 is we don't have. So whatever the missing functions I'm writing here, h of 0, h of 1, h of 9, h of 0 is equal to 10, and h of 2 you may get as minus 0.026, h of 3 is equal to minus 0.104, h of 4 is equal to minus 0.204. Like that you write. Now next is, this is the transfer function of the realizable filter. Next is, actually if they are asking us to find out the transfer function, so till here it is okay. Next is, but they are asking us to find out the magnitude response, right? For calculating the magnitude response, this is the formula. H bar of e power j omega is equal to sigma n is equal to 0 to n minus 1 by 2 an into cos omega n. So an is equal to, you will get how to find out the n value, a of 0, n value again is rolling from 0 to 5, right? So a of 0 is equal to h of n minus 1 by 2. This is the formula also you have to remember. And a of 1 is equal to 2h into n minus 1 by 2 minus of n. So like that you substitute. So this is the h of a of 0 value, rest of the things a of n value, this is the value. So a of 1 is equal to 2 into h into n minus 1 by 2 means 5 minus 1 is equal to 2 into h of 4. Already h of 4 we have, 2 into h of 4 you write, you will get 0.4104. Like that you calculate the a1, a2, a3 and a4. So this is the function of this one. So 0.75 into 0.4104 into cos omega. So here you have to substitute, right? So a of 1 into cos omega 1, a2 into cos 2 omega, a3 into cos 3 omega. You will get a1, a2, a3 using these formulas. Substitutions. After substituting that, you have to plot the frequency response. You need to have the values of omega with respect to h of e power j omega. So you are taking the degrees. You can take the 0, 15, 30, 45, 60. I like that. You can take 0, 10, 20, 30, 40 also. But so omega is equal to 0 means you substitute omega is equal to 0. You will get here in this equation. So h of e power j omega is 0.07 and modulus of h of e power j omega in dB you will get this. After having these values, you can plot this equation. So plotting the magnitude response is little heavier. but you can do it if you don't have any choice to write in the examinations. But mostly you can learn till here, transfer function of the realizable filter. So for explaining purpose, I have taken the very lengthy sequence till n is equal to 11, but in the examinations you may get n is equal to 7 only. So n is equal to 7 means you are going to find out 7 minus 1 by 2 means 3. So you are going to find out for only 3 values. For explaining purpose, I have taken almost 5 samples. 5 n is equal to 11 large values. So thank you. If you have any doubts and in this problem solving, you can comment me in the comment section. Thank you so much.